Solving systems algebraically. This is an Algebra 1 review. When we're solving linear systems, there are three methods to solve: substitution, linear combination, and graphing. We use substitution when one equation can be solved for either x or y. So first, analyze your two equations and determine which equation can be solved for either x or y easily. The first equation has a y with a coefficient of positive 1, so let's use that. 5x plus y equals 6. In step 2, we're going to solve that equation for either x or y. So in our case, we're solving for y, so subtract 5x from both sides, and we get the equation y is equal to 6 minus 5x. Then, in step 3, it says substitute the expression into the other equation for the isolated variable. So we're going to substitute that expression in for y in the other equation. So we have negative 5x plus 3, and instead of that y, we're substituting in 6 minus 5x equals negative 22. So in order to follow step 4, solve the new equation, we need to distribute this 3. So we get negative 5x plus 18 minus 15x equals negative 22. And then negative 5x minus 15x is negative 20x plus 18 equals negative 22. Then we need to subtract 18 from both sides, and we get negative 20x equals negative 40, and then divide both sides by negative 20, and then we get x is equal to positive 2. Then we follow step 5, substitute that answer back into the equation in step 2. So this is our equation from step 2, and we want to take that value of 2 and substitute that in for x here. So y equals 6 minus 5 times 2. So y equals 6 minus 10, and y equals negative 4. So our final answer is going to be the coordinate point 2, negative 4. That is the solution to this system. We use linear combination when you can eliminate terms by adding or subtracting the two equations. So first, analyze your two equations to determine which variable has the same coefficient in both equations. The x's have 4 and 3. Those are not the same. The y's have 7 and 7, so we want to eliminate the y's. Step 2, make sure the x's, y's, equal signs, and constants are all lined up. So the x's are above each other, the y's, the equal signs, and the constants. Then you need to add or subtract downwards to eliminate one variable and create a new equation. So I'm going to put an equal sign here, and since we have a positive 7y and a negative 7y, we're actually just going to add them. So we're going to add straight down. So 4x plus 3x is 7x. 7y minus 7y gives us 0y. And then equal signs come down. Negative 10 plus a negative 4 is negative 14. So we move on to step 4. Solve the equation for the remaining variable. Since we've canceled out the variable y, we can just solve for x by dividing by 7 on both sides. Then we're left with x is equal to negative 2. Then, in step 5, substitute that answer back into one of the original equations. So we're going to take that answer for x, substitute it back into one of the original equations. It doesn't matter which one. I'm just going to choose the first one for no particular reason. 4 times negative 2 plus 7y is equal to negative 10. So let's solve this equation for y. That's our step 6. Negative 8 plus 7y equals negative 10. And then we're going to add 8 to both sides. We get 7y is equal to negative 2. And then divide both sides by 7. and then we have y is equal to negative 2 over 7. So our final answer is going to be negative 2, comma, negative 2 over 7. And this is the solution to our system. Now we'll use graphing when the equations are both written in y equals mx plus b form. Since both of our equations are written in slope-intercept form, we can use graphing to solve the system. So step 1, graph both equations on the same coordinate plane. So this first one, I'll graph in red. We first graph the y-intercept, which is negative 5, and then we use the slope negative 2 over 1 to go down 2 over 1. And then remember, if you want to create another point, you can, down 2 over 1. And then you want to graph your line. And then we'll go ahead and graph the second one. I'll make this one in green. Y-intercept of positive 2. And then we have a slope of positive 3 over 2. And again, if you want to make another one, down 3 over 2. And then we can actually graph this line. And then identify the point of intersection. So the point where they intersect is actually this point right here, which is negative 2, negative 1. And that is the solution to the system. So again, this is an Algebra 1 review of solving systems of equations, which we're going to use in Algebra 2 material with solving systems of quadratics. That's it for these notes.